write down a series which approximates the improper integral of e to the minus x squared dx between the limits of 0 and infinity. So it's open at the top end. Okay, so when we say, remember, this is a series of rectangles. So what we do for the series, we're going to say, well, the integral between 0 and infinity of e to the minus x squared, we're going to approximate it as a series of lots of rectangles with width 1. So remember, the area of the rectangle is width times length, and we would normally, for a Riemann sum, we'd pull the width out, but if the width is just 1, it doesn't make any difference. We can just add all the heights. So we can say, well, this is approximately the same as a series which from I equals 0 to I equals infinity of e to the minus I squared. It's literally that simple. Remember, this just gives a lot of, it's a series of rectangles. This is maybe f of 0 plus f of 1 plus f of 2 plus f of 3. That's effectively what we're doing. And they're the heights. Remember, f of x is always the height of the rectangle. If it was a Riemann sum, something like that, we would have this common width here, but because it's 1 anyway, this is just fine. And for them to have width 1, you might think, well, that's a bit wide, but because this is going all the way up to infinity, I mean, width 1 is actually not that bad. There'll be plenty of rectangles once we get somewhere nearer infinity, which doesn't really make sense in itself. But yeah, having loads and loads and loads, you're talking thousands and millions of rectangles, all of width 1. It will actually approximate the integral very nicely.